Here we'll talk about angles between sets of parallel lines. On this picture, I've labeled one angle with the number 130. This tells you that this obtuse angle that I've labeled is 130 degrees. Using this information, we can find the measures of angles A, B, and C, which I'm indicating on the picture. Let's first start by finding the measure of angle A. We can see that near the 130 degree angle, we have a set of two lines, and these two lines make an X shape. We can also see that angle A is opposite of the 130 degrees on that X shape. Any angle that's opposite another on an X shape like this is called a vertical angle. The rule about vertical angles is that they are exactly the same number of degrees. The word we use for angles that are the same number of degrees is congruent. This means that since we have 130 degrees and A is a vertical of it, that means A must be 130 degrees. Let's label that on the picture. With that in mind, we can move on to angle B. We might notice that angle B and our 130 are along the same straight line. I'm going to color that in blue now. That straight line I've labeled in blue covers the 130 degree angle and B. But now remember that a straight line is 180 degrees. Since the 130 degree angle and B are on the same straight line, this means that B plus the 130 must add to 180. Now to find angle B, we can do a little bit of algebra. We can write down that B plus 130 equals 180. To find B, we can do the opposite of plus 130, which is subtraction. If we subtract 130 from both sides, 130 minus 130 on the left will cancel out. This leaves me with just B. Then on the right, we take 180 minus 130. We'll get 50 for our answer, and that means angle B must be 50. We label that on the picture now. Now if we look to angle C, we might be able to see that X shape that is between B and C. Since B and C are directly across from each other on that X shape, that means that B is vertical to C. And that also means B and C are congruent. This means the angles must be the same. Since C is a vertical angle to B, and B is 50 degrees, C is also 50 degrees. So now we know the angles of A, B, and C. We'll take care of the other angles on the next slide. Now we move on to angle D. It may seem as though we have no way to figure out what D is, but let's notice its relationship to the angle that's 50 degrees that I'm boxing in now. Since we know that angle is 50, we may also notice that 50 and D are along the same straight line. There's a theorem that says that if we are along the same straight line, and the lines that cross that line are parallel, that this 50 degree angle and angle D are considered opposite interior angles, which is a special case. Since 50 and D are along the same straight line, we can say that 50 plus D must add up to 180 because of what we know about straight lines. Since 50 plus D equals 180, we can find out what D is by subtracting 50 from both sides. This will get D by itself. On the left, we take 50 minus 50, and on the right, we take 180 minus 50. 50 minus 50 will cancel out because that's 0. And then 180 minus 50 is 130. Therefore, we can say that D is 130. Now notice that if we're trying to find D, D and E are also along the same straight line. I'll color that orange now. This means that D plus E must add up to 180. We already know D is 130, so we can say 130 plus E will add up to 180. Once again, we can subtract 130 from both sides. On the left, we know 130 minus 130 cancels out, and E will equal 180 minus 130. That is 50 degrees. Therefore, now we know that E is 50 degrees. This new 50-degree angle we just found for E is another special kind of angle called an alternate interior angle. Note that it's the same as the 50 degrees we boxed in when we started. This alternate interior angle is on the right side of the cutting line rather than the left side, but it's also on the bottom rather than the top. The angle we started with was on the top and the left. Effectively, everything about its direction is the opposite of angle E. It turns out if you have parallel lines, that 50 we boxed in and angle E must be the same every time, and that's called an alternate interior angle. Finally, if we look to angle F, we might see that it is inside of an X shape and it's directly opposite of D. Since it's directly opposite of D, we call it vertical to D. This also means that it must be congruent with D. Therefore, without doing any more additional math, we know that since D is 130, F must also be 130. Therefore, using the principles of opposite interior angles, alternate interior angles, and vertical angles, we can find all of the measures of all of the angles in the shape. Note that this only works if you have parallel lines. If you have lines that aren't parallel, this no longer works and you would have needed more information. But if the lines are parallel, we can find what all of the other angles are just based on knowing the 130 we started with.